In the previous video, we learned that a pointer is a variable that holds the address of another variable. We saw that the ampersand operator gives us the address of a variable, and that the star operator is used to dereference a pointer. In this video, we will look at changing the memory pointed at by a pointer. Let's step through this code quickly in the memory visualizer. First, I is declared and assigned the value 7. Then PT is declared. It is type int star, or pointer to int. That means that PT's value should be the address of an integer, but it hasn't been initialized yet. Then PT is assigned the address of I. When this next line is executed, the left-hand side is star PT. That's PT dereferenced, which means that the result of the right-hand side should be stored at the location PT points to, not in PT itself. So although PT's value doesn't change, the value PT points to changes to 9. Now what has happened to the variable I? PT pointed to I. If we look at the output of the print statement, or at I in the visualizer, we confirm that its value has changed to 9. I and star PT are aliases. They're both a way to get to the same location in memory. Now let's add one more line to our program and trace it again in the visualizer. Let's remind ourselves of what happened when this line executed. A stack variable j was created. J's type is int. J's initial value is the result of evaluating the expression on the right-hand side of this assignment statement. That expression is just I, so it evaluates to 7. So J's initial value is 7. Carrying on, PT is declared, PT is assigned to point to I. So now we have two locations in memory that both hold the value 7, and PT points to one of them. If we change the value stored in the address pointed at by PT to 9, then only that value changes. Both star PT and I refer to the same address in memory, but J is at a different address. Let's do one more thing in our program. We've just used star PT on the left-hand side of an assignment statement. That is how we assign to the variable pointed at by PT. And earlier, we saw the use of star PT on the right-hand side of an expression. That accesses the value pointed at by PT. Let's add a line that uses star PT on both the left and right-hand sides. To understand how this statement is evaluated, return to our model of how assignment statements work. The result of evaluating the expression on the right-hand side is assigned to the memory address from the left-hand side. Star PT evaluates to 9, and 9 plus 1 is 10. So this assignment is like having star PT is set equal to 10. 10 is assigned to the location pointed to by PT. And indeed, this memory location changes to 10, and a 10 is printed out. Before we leave the topic of assigning to pointers, I'd like to talk about a common gotcha. Consider this single line of code that declares variable PT and assigns it an initial value. What is the type of variable Q? Let me ask the question a different way. Is this statement equivalent to this option, int star PT, PT is assigned Q, or equivalent to int star PT is assigned Q? The first option is correct. As we've said before, even though convention has us place the star next to the variable name, the star in a declaration is part of the type, not a dereference. PT is a variable of type int star, and PT is assigned the value of Q. So the type of Q must be int star, and Q's value is assigned to PT, not to the dereferenced value of PT.